अपने नोट्स सेलेक्ट कर लो, अपने सारे सब्जेक्ट्स का अपना नोट कर दो, जो भी आपके सब्जेक्ट्स थे। याद है आपको सब्जेक्ट्स कौन कौन से थे? वो जो सब्जेक्ट्स थे सारे अपने सब्जेक्ट्स को उसका नोट्स है, मार्क्स और ऑब्जेक्ट ओरिएंटेड प्रोग्रामिंग।
तो सेम जो सब पहले और लॉगिन करते हैं तो प्रीवियस वाला लॉगिन करते हैं।
यही सब जैसे आपका कहीं कोई प्रॉब्लम आ रही है करने में, वो आप चेक करो सबसे पहले।
So very good afternoon, everyone. Am I audible? Anyone, please? Am I audible?
Yes, Vimlesh, you're audible.
Yes, yes,
Thank
yes.
you, sir. Thank you, ma'am. So
Yes,
welcome you all in this session. And this session, the expert of this session is Dr. Renuka Prasad B, Associate Professor, Associate Dean, Department of MCA, RBC, Karnataka, Bengaluru. Sir is highly enthusiastic and energetic person who always trying to bring changes in the way we mark the learning minds, more curious about adapting simple, innovative and scientific approaches in their learning and respecting the learner's freedom. Sir has done his Bachelor of Computer Science in 1999, Master of Computer Application 2002, and MPhil and PhD in Network Security domain. Sir has published more than 5 international journal papers and completed various research projects. So I welcome again in the session, sir. I hope the last session by sir, which is of very practical session, and this session will give you a very good concept in the field of Internet of Things. Dr. Renuka Prasad, sir, I welcome you the session. Please start your session, sir.
yeah, thank you. So, hello everybody. So today I'll tell you more about Raspberry Pi and how to work with Raspberry Pi and give a actual demo of how we generate alerts and demonstrate at least minimal concept of IoT. So I'll show you the setup and all that. So let me share the screen. Okay, so I think the screen is seen. So yeah, so is the screen, just respond? Is the screen? Can you see my screen, please? Just respond.
Your screen is visible, sir.
Thank you. Participants, please keep in mind my demonstration will be focused on Raspberry Pi and some of the experiments, some fundamentals I will introduce you. So within available time, so I assume that some of you might know Python, might not know Python. So still, I will ensure that if you don't know Python also, I'll ensure that very quick introduction is given and you all will be able to comfortably work with Raspberry Pi after this session. So that's the agenda. I'll show you some demonstration and a quick learning will happen so that it will create some curiosity for you to take it further. So if you have any questions later, you can ping me. Okay, so let me introduce you to the board first. Yeah, so this is one of the board. This is one of the board. Like yesterday, we used Arduino Uno. This is one of the board. So I'll show you how does that looks like. Okay, so this is the board. Yeah, some more please. Some different. There are different versions. My colleague is helping me with this. My colleague Santosh is helping. There are variety of versions here. So I think this is Raspberry Pi 3, Raspberry Pi 4, 0. Yeah, there are at least 3 versions here. So let me show you how they differ. So this is okay. Yeah, Raspberry Pi 3 model BV 1.3. So this is the model. Okay, so then this is a little older. Yeah, 1.2. Okay, 1.3, 1.2, but functionality is same. And this is Raspberry Pi 4 latest model. When it comes in a case, it comes like this, and you will also get enclosures. And you sometimes, if you wish, you can also buy Raspberry Pi keyboard and mouse. They are very nice. So I'm also using. So the advantage is that this comes as a hub. The keyboard comes as a hub. So when the keyboard comes as a hub, connecting multiple devices will be advantage. So that's about the Raspberry Pi. So now the same form factor. So there is another, yeah, sorry, the another form factor. So this is called Raspberry Pi Zero. So the Raspberry Pi Zero, all except 512 MB RAM, rest of the functionalities will be same. So when you build a solution and want to deploy solution at multiple locations and you are constrained with the space and power, so Raspberry Pi Zero is the solution. So in countries like UK, so these boards are given free to school kids in many schools to create interest in computing. But in our country, we have to buy all these things anyway. That's a different situation. And now, how do we use Raspberry Pi for IoT? So that's the agenda, or that's the session that will be focused on. And to tell you more about the Raspberry Pi 4, if at all you are planning to buy, if at all you are planning to buy Raspberry Pi for your works or for any of your research work, ensure that you buy the SD card, which is a speed of more than 100 Mbps. So I can show you a small card. How does it? What is the speed and all that? That cover itself will tell you. So it should be above 100 Mbps. Otherwise, the speed. If you put a low speed card on this, so this is where it will go. So this is where it will go. As in, you can see. So the SD card. This SD card is where the operating system that runs. So yesterday we have looked into the board, that is Arduino, which is based on microcontroller. So today we will use it on the one which uses microprocessor. It is Raspberry Pi 4. So now it has 4 GB RAM, multiple dual display. It has a dual 4K display support, Class C adapter, so DSI support and CSI support. So what does this DSI CSI support is? These are the devices that you get. Oh yeah, so my colleague got the card, this one. So please ensure that you buy the cards with this speed at least. So this is class C, I think class C 10 or something of that sort. So these are all high speed. These are all the high speed cards. Where they, yeah, you can see here. If you can, I can zoom it. Yeah, you can see here. 64 GB class C10 A1. So that's important. So here you can see here class C10 A1. So then even much speeder cards are available, but you should see here that at least 100 MB, capital M, capital B per second. So if you buy these, the speed will be very high. The input output speed will be very high. Otherwise, you feel that Raspberry Pi is waste, etc., etc., and all. So then, yeah, I was telling that yesterday we are using the board with the microcontroller. Today we will use with the microprocessor. This is Raspberry Pi 3. This is Raspberry Pi 4. I was telling about the support. The support is all same. Only thing is this has full HDMI. This is Raspberry Pi 4. This one. So it has Class C support, the Class C interface support. So this has full HDMI. Audio is same. The audio is same. Okay. So I'll take off this Raspberry Pi 0. Okay, almost similar. So then, yeah, I was telling about these are all the displays. So these displays, so this displays which has a touch display. Sometimes when you finish your project, you want to showcase. So you'll have to use this kind of these kind of wires, and you directly use it in the DSI support. So when we use the DSI support, the display and the refresh rates are good. So similarly, camera CSI support. This is specific camera. Yesterday I showed you two cameras. So I hope you have seen those cameras. So this is the wire. So this is the wire. So if at all somebody is thinking that I can do AI projects and want to use Raspberry Pi to take the pictures and upload, so this is how you can interface them. Uh, I'm not putting it completely. You'll have to pull this up, and you just have to push these. So anyway, and then to this there will be a camera connected, and that camera can be like this also. This is a small camera sensor. So there are a lot of applications you can build. So I'm just pointing what interfaces that are supported. Okay, then Raspberry Pi 4 has, of course, Bluetooth support. Then it has Wi-Fi support. Then it has Raspberry Pi even has two USB 3 and two USB. This is USB 3. This is USB 2. Then there is a LAN interface. So it's a single board computer. Okay, so this is done. Now, what is the major difference, or how do we immediately quickly start thinking about how do we use this board, Raspberry Pi board? How do we start using it for IoT? How do we use it for other purpose? Okay, since the session is about IoT, we'll focus on IoT. So there are other applications also, as in you can use it for day-to-day computing, etc., etc. All that is possible. Okay, so how do we understand about how to work on these? So please let me explain it to you. The card on board. Yeah, so consider that this is the one board. So this is the SD card that you get. Assume you get. Right? So how to start working? I'm telling you. I assume that you might not have used or you might have not have done. So that's why I'm just telling. So this is Raspberry Pi 3 or Raspberry Pi 4. You have SD card. So why do you need SD card? You need to install operating system on this, and that operating system should run this computer. Okay, why did we not use it? This is already put. This is Raspberry Pi 3. So why did we not put it for board like Arduino? Why did we not use it? Because Arduino is based on the microprocessor. So these are based on the microcontrollers. I'm sorry. Arduino is based on the microcontroller. These are based on the microprocessors. Microprocessors cannot just run like that. They require a full operating system. Now on this SD card, we use an operating system. So here, now the focus will be here. Okay. Yeah. So what is the operating system that runs? So the operating system that runs on this is one of the variations of GNU Linux. So what is that GNU Linux? So GNU is not Unix. So more information you can check gnu.org, gnu.org. So you check this link, you will understand. GNU plus Linux. So there are different distributions of GNU plus Linux. You might have heard of Ubuntu. You might have heard of Fedora. So you might have heard of Arch Linux, and you have the freedom to even make YMCA Linux. So there are no restrictions because they are free and open source software. So now on this SD card, we are supposed to install an operating system, so which is a variant of GNU Linux. So what is that name is? One of the operating system I'm telling. So there is a most famous distribution. There is a most famous distribution called Debian. Okay, which is a mother for all these Ubuntu, Arch Linux, etc., etc. Okay, and you have Raspberry. Raspberry Pi. So Deb, so Debian. Okay, so this is Deb. Packages are Deb. So now, so it is taken here. This is together. This is the operating system that has to be installed. So what is the operating system? So this is also GNU Linux, one of the variations of GNU Linux. Linux is the kernel. So please keep this in mind. Don't call it as operating system. GNU is the operating system. One of the variations is Raspbian. So Raspbian is what we need to install. There are other operating systems you can explore, but what we are using we will tell you. Okay, so this is what we should do it. Okay, now what does the operating system provides? Operating system provides some basic utilities. So basic utilities means basic commands, and then it provides development libraries. So what are those development libraries? The libraries can be from C, Python, etc., etc. It provides some applications. So the applications can be related to office, education, etc., etc. Okay. So this is the overall picture of the board that we use, the operating system that we use, and the SD card that is required. Okay. So now already we have installed, so we will not be able to show you the installation aspect. I'll show you how to directly work on that. How to work on that? How do we access? Now, what is the difference here? So let me recall. So let me recall. What did we learn? Very quick recall about what did we learn yesterday and how do we progress today. So yesterday we used Arduino to program our physical world. So how did we program the physical world? Either to monitor or, I mean, we did that to monitor or control a physical quantity. So again, I repeat the same thing. Programming the physical world. Now, instead of Raspberry Pi, instead of Arduino, we use Raspberry Pi today. So this is the board that we will be using. Of course, we will connect sensors or actuators, etc., etc. So in the today's session, so the key difference is that the way in which we use these pins. So how do we do the programming? Program the physical world. We program this board. So this board has the provision to connect to these pins. So these are the pins we will be connecting to. Variety of pins. These pins are exposed. Okay. So these pins, when they are connected, we have to use a language like Python. You can use other languages because Python provides libraries. So libraries to access the pins. What pins? GPIO, general purpose input output pins. We use Python. Okay, that is the purpose. Otherwise, and also you will have a full-fledged operating system running where networking utilities are required to push the data to remote places, etc., etc. So either you use a sensor or actuator. Okay. So why do we program the physical world? Either we may want to monitor or control a physical quantity. So same aspect. This is what we will do today. Okay. Now assumption is that operating system is downloaded and it is extracted onto the SD card and it's already installed and it is booted. So assuming that, we will proceed further. Okay. So how do we start? So to start with, directly we cannot go to the program. Of course, we need to understand. We need to understand. We need to understand how the programming is done. So then, so how do we work with the Python programs? So if I start directly with Python, you may feel that okay, we should learn Python now. What is the use and all that? That feeling may come. So I will make you understand the necessity of it. Then you will value the need to learn that language. So there is a small setup. So I want you people to keep in mind till the end of the session, so that you will understand what is that we are going to do. I'll turn my camera and show it to you. What is that setup? Okay. So there are several. You can see here. There's one Raspberry Pi. There is one Raspberry Pi here, where three LEDs, one button, and DHT11 sensor. That's temperature humidity sensor is connected, and that is as of now connected to this monitor. So then there is one more Raspberry Pi beside it. There's one more Raspberry Pi beside it. Okay. So 1 second. There's one more Raspberry Pi. Where is that? Yeah. So that's the one, but it's not connected to any of the monitor because after working on to this, we will see what programs that they run. Okay, but it's powered on, and some programs are already running. And of course, I do have one more. Yeah, this is in the extreme. So this is what I told and promised yesterday, where we will show you how to send an email, when a button is pressed. Okay. So, and this one is connected to this particular monitor. And already I have tried this, as in you can see, if I do a little bit, probably you will understand. Yeah, already I have tested that program, so that is working. Yeah. So that program is working, so I'm able to send email. So how do we send that email? Yesterday somebody was asking, are we using any GSM module? The GSM module is for connectivity. So since here we are already connected to the LAN, so you can see here there is a LAN connected either through LAN or Wi-Fi. So assumption is that there is internet connection, and then we are doing this. So there is already, it's done. I tested before the session. And here I will show you how to work with the fundamentals. So keep this in mind that there is a Raspberry Pi, there's a button there, and there's a button there, and there is a DHT11 or a temperature humidity sensor, and three LEDs are there. Okay, so that is a Raspberry Pi, which I will be showing some demonstrations now. Okay, my colleague will be typing the program, and let's see how the things move on. So before going on to that, so I want you people to know a little bit about Raspberry Pi configuration, Raspberry Pi pin configurations, so that you will not be lost. You will not be lost later about when the things are happening. Okay, so let me just arrange the stuff. Okay, things are fine. Yeah, so this is okay. Okay, so let me, yeah, my intention was to tell you why we have to understand that there is a need for learning Python program language. So to understand that, let me run a program and show it to you first. So then you will probably feel that okay, there is a need to learn the language. So very quickly, please remember, so the setup, let me show you the setup here. Setup as in, 1 second. Yeah, now I understand. Okay, cool. Yeah. So here, the pin configuration of this, let me tell you what is the pin configuration of this. Yeah, this is the setup I told you. Yeah, so this is the setup I told you. So let us understand the pin configuration. I'll write down what is the pins that are connected. So I'm writing, just a moment. DHT11 sensor, the data pin is connected to pin number 10, and LEDs red, green, blue, 29, 31, 33, 29, 31, 33, and then button is connected to pin number 30. Yeah, please put this. There. So this is the little this one. Yeah, this is the table. So this is the connections that we have. But now you may feel that, okay, we don't know what is the connection, or we don't know how these are connected and what are the configurations. So how do we understand? How do we understand the board? First of all, we should understand the board. So then only we will value why I'm telling the pin numbers and all that. So now it's the time to show you the board and the pin configurations. So if at all you are you're thinking that the board is like this, so how the numberings are done, so that's what the discussion will be about. The discussion will be about. Okay, so I will tell you how these numberings are done. So you have seen that the board is kept like that, and this is the exact picture. There's another picture. Okay, so there are two conventions. The configuration aspects I have told you. Okay, and the chip is manufactured by Broadcom. Broadcom company manufactures it, and all other features I have explained you. Now on top there are 40 pins. Okay, how do we know that? Yeah, so this is the image. Exactly the same way, the board is kept, and you can see the 40 pins. Without knowing this numbering, you will never be able to understand how do we do the program, and just blindly, otherwise blindly people just using it. Because to work with Raspberry Pi, we need to understand the pin configurations, we need to understand the Python and the library it provides. Without knowing that, if you start using it, so it's like just blindly you run the programs. Okay, so now if you observe these numberings closely, so these are all the numbers which there are two conventions. What are the two conventions? So the first convention is the physical ordering convention. Okay, how do I know that? Let me show you from the Raspberry Pi. Let me show you from the Raspberry Pi itself. Okay, this is a screen I'm tilting towards the Raspberry Pi now. So there are some basic commands which you will execute, and that will help you to understand what is the configuration or how the pin configurations are done. So my colleague will help me with the commands. So open the terminal, Control Alt T is the terminal. We're working on the Raspberry Pi right now. We're working on the Raspberry Pi. Uh, okay, so just trying that. So hold on a moment. Yeah. Okay. So cool. So Control Alt T, Control, yeah. So enlarge it. Alt, yeah. Control Alt T will launch the terminal. Control Shift plus plus plus. Yeah. More, little bit more. Yeah. Enough. Some more. Yeah. Good. Good. Enough. So pinout. P-I-N-O-U-T. So pinout is the command which will tell the pinouts of the device that is connected. You scroll up, you can see it will show an image. Scroll up. It will show an image of the Raspberry Pi model, and it is the one which is connected to Raspberry Pi model 3B version 1.2. So then SoC is system on chip. System on chip BCM2837 is the code. Then you have RAM is 1024 MB, that's 1 GB RAM. So then you have 4 USB ports, then one Ethernet port, then one Bluetooth, Wi-Fi, display CSI ports. After that, it is showing some numbering. Scroll down. Yeah, so we need to understand this numbering. So this is how the numbering. So in this image, it is tilted 90 degree. This is a image that is where the device is kept like this. You can see the image. You can see the image. How you should imagine is that. How you should imagine is that you should keep the Raspberry Pi like this near the screen. Up. Yeah, you should keep the Raspberry Pi, hold it like that, and this is what you will see on the screen. Okay, I mean, this is what the numbering is. So now see the number. There are two lines of pins. There are two lines of pins. In the image on the screen also it is showing, and as well as in the hardware. I think if you Google, you will be able to see, or else you can see my streaming video. Now there are two lines of pins. One is towards the processor and one is towards the edge. So towards the processor, which are marked here in little orangish, not orange actually, pale yellow, they are odd number. Towards the edge, they are even number. So the exact numbering and the color pattern is provided for a clarity purpose. If you look at all the black colored ones, they are the ground pins. If you look at red color, they are the power pins. 2 number 2, number 4, and then number 1 and 17. There are other pins and different purposes. As and when the application comes, you will understand. But they can be used as general purpose input-output pins, like we used in Arduino. Okay, now straight away, control minus. So straight away, let's understand how do we work on with the sensor. Then you will feel that I should learn the Python. Okay, go to that editor, Thony. So I hope you remember ds.py. I hope you remember the setup that we had, whatever the setup that we had. Okay, so now let me show you. Let me increase this font size a little bit. I don't know where it is. Okay. So let me show this in the normal editor and zoom it a little bit. I think you may not be able to see this. Let me just show you. Okay, stop this. Okay. Anyway, so I will not teach immediately the program part. I'll just show you one output, so you will understand. You just see this area. You just see this area. It is showing temperature and humidity, so it is able to sense something. Okay. So because it is connect. Now you may feel, what is this? Suddenly you started all this. So how do we start programming? How do we start working? Why do we need Python for it? This is a Python code. So if I tell this is a Python code, you will not understand. So that's why I told, let us understand the language first and the library that it supports. So then you will value is what I was trying to convey. Okay. Uh, okay. So let me very quickly introduce you all to Python. So Python is a very simple and object-oriented programming language. The learning curve is very simple. You can easily learn Python. You can easily learn Python specific to a particular domain also, because a lot of libraries are inbuilt and they are provided. As in, could that be related to the biotechnology? Could that be related to the mechanical engineering? Could that be related to any other branch? There are a lot of libraries people have developed. So only thing is, of course, the speed and all that. Yeah, so it comes with the feature, so you can't do anything about it. So let me start how to use or how to start working on Python. This is on Raspberry Pi, and when you launch terminal, so if I type Python, it will launch the terminal. It will launch the Python version that is installed. So as of now, Python command is associated with the Python interpreter 2.3.13. So Python is an interpreted language. Please understand, it's not a compiled language. So the interpreter works line by line. So the one which I have opened now is the interpreter prompt, Python prompt. Okay. So there are different ways to work on Python programs. I'll show you slowly. Okay. So let me plan the session. Okay. Now, cool. Okay. So now Python programming language. So let me say, I just say hi. It says hi is not defined. So hi is equal to 5. Then I say hi, it says 5. So now, very quickly you are able to, the learning curve is so small. Please do not compare the programming languages like say C is like that or C++ is like this, Python is so like that. We should all go by the features. Depending on our application, we should understand how the features are developed or how to use the features of a language. Now what I'm showing you is how to work with the Python program language. So language provides a lot of facilities, as in it provides some operators. It provides a way to write conditional execution of statements. It provides, of course, modularity through functions. So since Python is object-oriented programming, it also allows to define classes and do object-oriented programming for a specific purpose. Now the focus is on IoT. So what I did just now is declared a variable called hi, and I assigned a value, and the value is the integer value. So I did not tell what type it is. So then how does it take? So how does it take is, so you can understand from here when I say hi. So the beauty of Python is that based on the type of content, it assigns itself the type. Now say, so instead of hi 5, I will say 5.5. Now you see, so depending on the content, now hi can be it can be string also. See, so that's the beauty of it. Okay, well now, what are the things that we need to be familiar with Python to work on IoT? This is what some people will start getting confused. See, we should learn a language, there's no doubt about it. So Python documentation. So it has so many features. So many features means we cannot learn everything at once. So if you go with the documentation, you can go to the document page and see this is from the developers. So you can choose whichever the version you want, and whichever the version you want. So working with the older version is not advisable. Work with 3 and above. Okay, of course 2.7 you can do it, but now since people are migrating a lot of things onto 3, so it's always advisable to work on the latest stuff. Now, so how do I start? So like this, you have to log into or you have to check the documents of the Python, or you can use any of the textbooks and all that, and you can learn. So that's a quite simple answer. But then you will have to spend some time and apply it to some domain. Then only you will value it. Okay, what are the stuff that we have in a language, or what are the features? So you can see here typically what they'll expect somebody to know. So they'll expect somebody to know about how do you declare variables, how do you use statements, if statement, for statement. So then how do we use functions, then the data structures, then of course how the modularity, etc., 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 etc. Okay, so you should learning language is one thing, and but don't keep on thinking that you have to learn a language and then start working on IoT. There's nothing like that. Parallelly, you can go on and do it, and you should have confidence. If you know one language, you can easily migrate to other. I mean, except the syntax. So now let's look into some more features, and then quickly go on to how do we use the Raspberry Pi board. Okay, so A is equal to 5, B is equal to 4, C is equal to A plus B, so display C is equal to A minus B, means essentially arithmetic operators are supported. Arithmetic operators, bitwise operators, logical operators, these are supported. Okay, and of course when we want to see some statements, uh, I mean, you want to print something, you can just do that, or you want to print some value, You want to print some value, you can do that. That was why. So print A. So you can merge, you can club the, you can club the, you can club the string also. Okay, next, what is that we need to be familiar with so that we can move on? So, okay, all this, whatever I'm showing is all in the Python prompt. I can put all of these statements in a program and run it as a script. That's what I'll show you now. Nano is a simple editor. Nano is a simple editor. YMCA YMCA1.py. Py is a short form of Python. So I can put the same statements here. I can say print hello all. The next statement will be A is equal to 5, B is equal to 6, C is equal to A plus B. Print C value is okay, and you have to save it as you have to save, and this is called Python script .py. So that name is ymca1.py. So how to execute Python file name? So see, this is a Python script. Got it? So earlier what we did? Earlier what we did was the Python prompt itself. So I want to quickly try, learn, interpret something, and try small things. This is a good thing. Now let us look into the for loop. Okay, so for I in range. So this is how the syntax begins. So no need of brackets. So the colon will signify that the start of the for block, and 2, 3, 4. 4 indent spaces will tell that that's they are the lines included under that block. See, it's a simple form of for loop. There are 2, 3 types. For you can of course the same statement. I mean in a different steps, like instead of one step at a time, if you don't mention anything, it's one step at a time. So if you mention, okay, so then see, so there are different ways to do it. You can do reverse also. So from 100 to 10 in the scale of -10. Oh, sorry about it. Oh, same thing I executed. Anyway, so that's about the for loop. If you can put for loop within another for loop. So then while loop. So yeah, only one example I'll show. I understand that all this may look funny, but I have to, or maybe boring. I don't know, but you have to understand this slowly. You will value how will I take it this to the IoT. Okay. So then 1, 2, 3, 4. Print. So the same aspect in the while loop. Okay. So of course you can have while loop within the while loop, for loop, while loop over. So now the if loop aspect. So here is where slowly I'm just taking you to the next level, and there are of course different libraries also. You will understand. Now keep this in mind. One more thing. Say a is equal to 16. I want to say sqrt of that is square root of 16. See, it says sqrt is not defined. Means certain there are certain modules will provide these functionality. Like say in math has a lot of such functionality. So now what I will use math.sqrt of 16 if I say will calculate. Means math is a module which will have a lot of functions like the sqrt which does this computation. Means sometimes now this is the key aspect here. So to do mathematical computations, we imported mathematical libraries. To do Raspberry Pi related, we have to use or we have to include Raspberry Pi related libraries. So that's the key takeaway out of this discussions while I'm doing it now. Okay, now let us just quickly get into this if loop, if else loop. Okay, if else loop, and then directly move on to the IoT. So, I mean, what library do they use and all that. Then with the functions, then finally I will show you the email program. So that's the end of the sessions which I'll do it. Okay, now if loop. So what is the purpose? All this you can think of. Assume that I'm checking the address checking the address. So input is the function name which will take the inputs from the keyboard. So uh, so I just want to prompt a question to the user. Prompt a question to the user. Okay. So then if okay, what is this? Yeah. So it's just taking that. Okay. Why is not defined? Okay, that's fine. So now this is one statement. So now let me, since there are more lines, so let me just add these. Sorry, let me add this statement. Let me add this statement to. Let me add this statement to this file. Okay. So let me check the address is equal to. I'll take the input from the keyboard and store it there. So input is address right. So since I do not want to immediately execute, so I want to ask this and then proceed. So that's the point. So then 1, 2, 3, 4, print your address is saved. So we'll delete that address, then print your address deleted, try again. Okay, so let's see what does it do or if there is any error. Okay, what is the error? Okay, indentation. It's correct on 1, 2, 3, 4. Okay. 4 spaces are considered as the proper. Oh, sorry, line 3 itself. Oh yeah, I understood. So every block should start. So every block should start with a colon. Ah. Oh, sorry. I think I made a small mistake. Kindly excuse. What I have done is I'm trying to do this. I'm not putting the if statement at all. So if chk address is equal to yes, then these following statements should execute. Okay, that was my mistake I was trying to do. Okay, your address is saved. Yeah, there is again one more. Yeah, so here it was a mistake. Let me correct it. So you will also understand how to correct these mistakes. Okay, so good. I will say yes, something. Y is not defined. So then I will say yes. So then it will take, oh, yes is not defined. Okay, I will go and check what is defined. Okay. If check address is equal to yes. Okay. Just a moment. Okay, cool. So I think there's a difference with the Python 2 and 3. So well, that option is working now. Let me just quickly move on. So otherwise you keep doing the same things. So if is done, if this is equal to S, so else if, else if, so I can use elif, chk chkaddrs is equal to no, is equal to no. Four spaces. So print your address is saved. If it is saved, print your address is saved. Else if it is no, else if it is no, you can delete that address. Now you can change this option. You can change this option only if it is no, only if it is no. So my idea is to tell you, convey you that. So if, else if block. So if and so if that is not, so take this block 1 2 3 4 and then so delete the check address. Okay, so then comes the normal one print statement. Print your address has been deleted. address is deleted. Your address is deleted, and try again. Something like this. Okay. So then comes else, if, elif, and else also is possible. Okay. So else you can. Okay. Let's see some errors whether it will prompt or not. Print invalid input. Okay, so let me just check whether it was going to execute. Yeah, I expect as expected. So I hope you have seen this. We should provide the colon as the start of the block. Okay, so this is done. Now, basic stuff is done. Now, how do we move on with the IoT? So what are all the things covered? So what are all the things covered? Raspberry Pi, basic introduction to Raspberry Pi, what is operating system used in it, working on the terminal, and then basic Python commands or the basic Python language features. Then slowly, how do I take this knowledge from this knowledge towards working with the IoT. Okay, so I request you to remember this setup. Please remember there is a button, LED, and temperature humidity sensor. Now what I will do, I will show you how do I transit, we get transition from the normal Python program to the IoT. Okay, so I will first show it on the command line. So then I think you will understand. So you will understand how do we relate it. How do we relate it with the? How do we relate it with the um, shell script? I mean, sorry. How do we relate it with the Python script that you run on the shell? Okay. So first we should button is press print. Okay, so let us work on a simple. There are two libraries. There are two libraries. To work on this, we need to follow two conventions. Okay, the two conventions I told you. One is the board mode. So GPIO read all. So these are the two conventions. The numbering convention. This is a physical pin number convention. At the center, what you saw, the colorful image earlier. So that's this convention is called a physical numbering or the board convention. The another one is what you're seeing at the last, BCM convention. So these are the two conventions which we should be aware of. So BCM means every chip manufacturer will have their own way of numbering the pins, and some developers will develop with their own conventions. So they will mention what is the numbering. So what matters finally is where do we do the wiring. When we say put up board in a particular mode, then we will have to number them accordingly. Okay, to understand this, let us do a simple quick program with the LED or with the DHT. So then you will understand how to use this library. Okay, so I do have a simple program to do that. So let me show you those programs. So very quickly, so I will not waste time on the typing part, so that you will not miss out. Yeah, so I do have this program. Let me just show you. Yeah, so let us take these things and run on the Raspberry Pi. Okay, so how do I show this? Let me keep pointing at this. Now you can see here. So I repeat, this is a program that is there on my laptop which I'm presenting. I'll just execute that. I'll just execute that onto this on the Raspberry Pi to make you understand the board, this convention, numbering convention. Okay. So first of all, I should import a particular library. So to make you again recall this, what is that library? I remember what did I do with square root of 16. So it said I don't know anything. Then I said import math. So then math.sqrt of 16. So SQRT of 16. So gave me a very good knowledge about how do we import modules. Same way, we have to import modules or libraries provided by provided by the sorry, one second. Yeah, provided by the developers or the company in which we are using. So where are the developers? So RPI. So there is a first line, if you observe, that's the library. So how do we use it? See, this is the first line. So like we imported math, I have to say import rpi.gpio as GPIO. GPIO is the library name, rpi.gpio is the library. If the library is there, it will not prompt you any error. Now then I will have to set this particular mode in GPIO dot line number 4, set mode, GPIO dot set mode. I should put it in the BCM mode, BCM mode or board mode. Okay, I can show you the both. So this board mode. So when we say board mode, the numbering that we follow, is this at the center. Okay, I have connected. I showed you already what is the connection details. As per the board mode, I have connected the LED to red LED to 29, then 31, 33, green and blue LED. Then the button to pin number 32 and DHT11 to pin number 10. So this is as per the board convention. Okay, that means essentially anode. Okay, this is some program LED pin out. So as like we did in the Arduino, first of course we didn't set any board there. So here the board is set. After that we'll have to tell which pin, what is that you want to do with that. So GPIO dot first set the mode of the board. We have done that. Then set up a particular pin. So we have to set up which pin number. I told you red is connected to. So red is connected to pin number 29. So in mine, so I will take that pin number 29 and I will say GPIO dot out. It says already in use, that's okay. It shows the warning. Okay, once it uses, then I'll say high low GPIO dot output. So GPIO dot, there are functions output. Now I hope you understood. Like I used math dot square root, there are different functions to do set mode, setup, output, input, and all. So the pin number, what is the pin number? So pin number is 29. Then I will say GPIO dot high. I will signify that an LED should glow. So now the same thing I can put it in low. Okay, now is the time for you to see this output. See, let me, yeah. So don't worry about only LED and DST. You can of course use other examples, but as a beginner, you should do this. So all that I'm doing is high, low, high, low. Okay, high, low, high, low. This is all in the command line. You can now see what I'm doing on the screen. On the screen, you should see here, high, low I did, and accordingly the LED started glowing and switching on and off. So this is what we did. So how did I give you a transition? So what is the learning outcome from this? So the learning outcome. So let me make it little bit more clear to you. So what did we do? So we started working on Python. Then we started using the libraries that are required to work with the Raspberry Pi so that we will understand how to work with the sensors. So once we understand how to work with sensors or actuators, so then it is quite easy to use any of those pins and access the sensors or actuators. Okay, likewise here the key aspect here is that the library that we used, so rpi.gpio library. Similarly, there are other libraries, so you should keep that in mind. Okay, now I have connected a button there. So let me come out of this, or I can execute from here also, but I would prefer to come out of this and show you one more. Okay, so there is another library. So one library what you saw is rpa.gpio GPIO. Now there is one more library called GPIO 0. So I have opened that documentation here. This is the website where you can see all of that. Okay, So I can directly, instead of typing, I can directly use this. Of course, from GPIO 0 import. Okay. Let me anyway doing GPIO 0 import button. So this will actually what it does is the whole of the button functionality gets imported like math similarly. Okay. Now I'll take a variable button is equal to button of. Please understand this library GPIO 0 library uses BCM. So when I uses BCM, so the button is connected to pin number 32. Please understand pin number 32. I have already told you this convention. Pin number 32 anode is connected to pin number 32. Okay, this is a pin number 32 that is connected. Okay, so I will say I'll initialize that. So how does it? What does it say? Non-physical pin exists for pin 32. So one second. Yeah. So we should understand what is the physical equivalent of 32 here. So the 32 is the physical numbering. The equivalent is 12. Okay. So that's why it is telling that it's not able to understand something. So let me change this. Now let's see. So now you can understand because I had connected to some other. When I say 32, there is no BCM 32, I guess. So that's why it was telling DPI 32 is not understanding. Anyway, so button is equal to pin. So one variable we have declared. Now, how to use the while function also, and also how to extend this to the IoT. So if button, that's a variable, button dot is 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 pressed. Again one more loop. 1 2 3 4 1 2 3 4 print button pressed. Okay. So now it is prompting or it is waiting. Now I will press the button. I don't know whether you will hear it. I will press it. See, and when I did that, so it's continuously telling that button is pressed. Because I did not add any stopping condition. It continuously started doing. So I hope you understood what is that I just wanted to convey you. Okay, when a button is pressed, because the else part is not done, button is pressed. So to improve upon that, uh, okay, if while true, okay. So wait a minute. Uh, okay, I'll take I is equal to 0. So while true, what I'll do. So if button dot is pressed. Okay, I should first define the button, right? Wait a minute. Okay, let's go one by one. Let me come out of this. Control D. So I repeat what I did. Let me just check the time. Okay. So now what I'll do, I will button pressed, and then okay. So I'll extend this program. I can extend this program. However, so when a button is pressed, you saw now the text message. But at the same time, hello, any question? Any doubts? Any questions? I heard somebody talking. I don't know. Somebody is sending some form. I think they could have shared it later after the session. I don't know what's going on. Anyway, yeah. So let me continue. Yeah. So how do we extend the same program? How do we extend the same program when a button is pressed when a button is pressed? How do we send the temperature in a particular room or a furnace or any industrial equipment? How do we send email about it if something it crosses? And how do we write functions for it? So we need to understand how to write a function. Now anyway we saw using while loop how did we type a message. When a button is pressed, some message is typed on the terminal. But we need to understand how do we make a function and then slowly extend that function to do some implementation. So very quickly I will show you how to define a function. So Python, so define my underscore function. So I'll define, okay, so function is a block 2, 3, 4. So print, I will say print, okay, I'll just stop this. So and I have to execute it, my underscore function. So it prints. Likewise, I can define a function, I can do some computation, etc., etc., etc. Similarly, when a button is pressed, how do I write a function? Okay, so the same for the same program from GPIO from GPIO from GPIO 0 from GPIO 0 import button. Okay, so then define a function called button underscore pressed. Define underscore function. Define a function called button underscore pressed. So here we can have a function print, and at the same time I can write a function to send email, but I will show that demo only. I cannot show you the I mean typing of all of that. Okay, so button pressed. Okay. So then at the same time, one more function, define button pressed released. So released, this is a colon. Oh, sorry. Define button released. Line 3. Okay. Of course, I can put this. I can put this in one program, so that will that will give you a better insight. Otherwise, you people will think that so that will create some kind of confusion. So what I'll do is, so all this I can delete. Can write you a script. So this is where you start writing the script and understand how things works proper professional way. So GPIO 0, so GPIO 0 import button. So then I define one function. So I can define a function. So then you can say print okay. So the same way define released. Okay, so then so now these two functions are defined, but then we will have to use the same logic according to the PCM. So the 32 is connected to 12, so I'll initialize that by passing the pin number. So and then there are functions provided in the documentation. You can see this documentation. So there are functions provided for buttons. You can see the same documentation. So according to that only I'm showing you. So button dot when pressed. So this is the inbuilt one. Inbuilt one is equal to button pressed. In same way, button dot when released. These are the functions that tracks the button press and release. Released. Okay. So this is to continuously execute. I'm just adding this. So let me run this. Python 3. Okay. Okay. So one small error. 1, 2, 3, 4, 5. Okay. One double quote. Okay, now it's waiting for me to press the button. When I pressed it, you can see pressed, release, pressed, release, pressed, release. Because when I pressed, one event has happened. When released, one event happened. So if you look at the code, so this is how it happened. Button dot when pressed, button dot when released monitors that status. Now, when we program the physical world, in the physical world, there might be input coming from some buttons. Either it could be a robot, it could be some motor switch or whatever. Okay, same way it can be touch sensor, same way it can be some other sensor. So you can track those values and then proceed it. So now I will extend this program and I'll show you the I'll show you the another one. You can see here. Same way, I will show you importing another library. There is a library called yeah. I will take this import. Yeah. Uh, yeah. So I'll import adapter underscore DHT to work with the temperature and humidity sensor. I'll assign a variable called sensor is equal to adapter underscore DHT dot DHT11 because that is the device that is connected, and pin 15. So the pin 15 means as per DHT11 the physical board, the physical pin, you can see here, physical pin 15. 15 is connected to, I think I have to check that. Yeah, you can see here the 10, the purple 10, physical pin 10 is connected to GPI of 15. So I should mark it as, I should mark it as the same. So that is the pin is equal to 15. Let me take that. Yeah. So copy here. Yeah, pin is equal to 15. Then while true, so I will read. So there is a function here. There is a function. This is from the library. So essentially, we are learning how to use a library. So you don't need to really worry about okay, how do I do this? How do I do that? Etc. Etc. So in the true, so here what I'll do. So in the while loop, I will read the humidity and temperature, and also also print the same. So print the temperature and humidity value. So when a button is pressed, that event also will happen, and you can also see that temperature and humidity is read continuously. This keeps happening. Okay. So now when I press the button, you can see temperature, humidity is being read, and it's waiting for the button to be pressed. But at the same time, the loops keeps executing only when the button is pressed, rest is happening. And when a button is pressed, I can also ensure that LED can be glown. So like these things can move on. Now, how do we extend the same program? Same program. That means we are able to read the temperature, humidity. So we are able to track the button. Okay. Now, how do we extend the same program to send email? Okay. So slowly I will shift this display. You can see here is another Raspberry Pi connected. I told you I've already connected that. Okay. So now, so where is the setup? Let me show you the setup. So here is the setup. So this is the setup where there are two buttons and one same DHT11. Now you can imagine slowly when tomorrow some solutions are built, could that be that sensor can be in a furnace, or sensor can be in some environment. It can be vibration sensor. It can be so many things. Okay, but you want to generate alert. Okay, automatically you want to generate alert or manually. Right now what I'm showing is manual alert generation, because only when some situation happens that those things should work. Okay, so now what I'll do, okay, so now I will show you the program and I will do a quick explanation. Then I'll show you how we receive email or send email from the program itself. Okay, so where is the program? One second. Yeah, so this is a program. Yeah, so this is a program. So I hope, let me adjust the screen. This file, references. Yeah, font I'll increase it. Yeah, I think this is visible. Now, please understand. This you saw there also earlier. This was for the temperature and humidity. Now this is for getting the time, date and time. Now then, some pause and some system functionalities. So the key here is about the SMTP lib. So SMTP library allows us to send email, and we will have to mention which is the server we are using. In our example right now, I am showing you the usage of Gmail's SMTP service, okay, and the port number, and these are all prefixed. So we have a variable to keep track of what is that option. I mean, what is the server we are using. So let me just increase a little bit font size. I think this will be more. Anyway, I think now it's better. Okay, I repeat once again, this is for the temperature humidity. Okay, so then this is for the importing library. See, all that we are doing is importing a library. Now, so there is email pwd is a file. So what is that file, where it is, I'll show you. So there we have to keep the uh, email and password. See here, email pwd.py file. So there you have to store email and password of your Gmail. So when we import, these two variables can be imported. So with these two variables, of course, you had seen earlier from this library how to work with the button. Now this try catch block is for the exception handling. Anyway, they're all syntax. So this is the first command to check hi hello with the server, smtp underscore obj dot ehlo, not helo, ehlo only. If this is success, it says that ping is successful. So if not, then there is some error. After that, there is a secure transport layer service. I mean, some service has to run. Then with this email and password, that is smtp object dot login is the function name, and if the email ID and password, you log into it. If that is successful, you should get a message successful. Okay. So I'm just showing you so that you will see some changes. I'm saving this. Okay, then otherwise error. So now I told you how to write functions. So there is a function here. How to get the temperature and humidity also I showed you. Okay, so this is the email content. These are all the syntaxes: subject, to user. This is how you write email. So that is a library which supports to do that. And when you say message, so all these things. So you this is a function finally, send email. So send email requires email ID, password, and the message. So and the message will have all this content and all that. So when it should happen? It should happen when the button 1 is pressed. When pressed, call this function email underscore temp underscore humidity. Okay, so this is a program. Of course, some other things I have removed. So I will run this for your convenience and confidence. So I'll run this. I'll close this here. So this is a program which was running earlier also. I will stop this service. I'll run this again. So I'll increase the font size. Okay, so this is how we run the program. Now see, ping successful, logging successful. You can see here. Where was the code? The code is here. First it checks whether it says hello to the Gmail service. Then login successful with email and password. So then comes other things. It waits for my input. The button one when pressed, then only the function is called. So when pressed, this function has to be called. In this function, temperature is read and then it is sent automatically. So instead of this say button, we can have a touch sensor. We can have some other sensor or some other condition. Okay, there may be the gas leakage, maybe some distance. If somebody is coming close, maybe there is a vibration. So there are so many things. It can be moisture. It can be so many things. Okay, this is how at the see what all I'm showing is at the back end what happens when you see in the front end certain things. These are all the way in which we should start learning or learning to understand how things works. Now you see, I press a button. It says email temperature and humidity values. Let's check my email. Already there was an email at some time. Okay, now I will refresh it. You could see one email, additional email, apart from the one which I had tested before this session. Now there should be one more. Let's see. Yeah, you could see that one more email has come, and you can check the time if you don't have confidence. I have zoomed it. I'm trying to open that. So what is the time in which? So it says temperature. Yeah. So let me open that. Yeah, you can see it. 3:51, 0 minutes ago. Temperature is 27, humidity is 95. At this date, this is the time. Some formatting issues are there. 15 colon something has to come. This 3:51 is the time. So that's the formatting. Why string handling has to be learnt is because of this. That's the Python issue. So I might have not handled that part here properly here in this line. Okay, so in this line, that is the email content. So string of temperature, string, and all these things are done. After that, I might have humidity is, and then now string something I might have missed, so that it's not able to get that. Yeah, this is where it is. Anyway, that's okay. So this is how you work, and I mean this is how you start generating alerts. So this is the one of the use case. Okay. Yeah. So any doubts, clarifications, if you have, you can make. I have done the demonstration of what was that I had planned. Okay. So if any doubts, clarifications. So now the session is open for questions. You can unmute, or you can send a chat, so I can check that. If anybody has any questions. So we have time, 7 minutes time for questions now. 7 or 10 minutes I can spend. So if anybody has any questions, so all, or if you want to send me an email, you can also send me an email. Do you have any YT channel? No. You can call me or you can email me. I can clarify your doubts. Yeah, what is this, sir? Can we make 3D printer with IoT? So the question can be something. Question could be maybe something else. See, IoT is something you should think of as a
दो बार
over
पेमेंट
network you
देना
do it. Over a network you do certain things. So locally you assemble something which a 3D printer can do it. So that's on Arduino you can do it. Okay.
राहुल और आसन ये दो भी 4 अगस्त के हैं कितनी है बैंक में 4 अगस्त की
I think somebody is talking there and disturbing. So I don't know who is that. Anyway.
20 ठीक तो है 37,000
So
Okay,
somebody.
is there any question,
ये मैं आपको लेटेस्ट वाली एक्सेल
participants?
शीट दे दूं
You have question, you may please ask.
ये आज तक की
पूरी आज की मतलब कि ये मेरे पास है
ये 13 अगस्त तक की है नहीं 17 अगस्त 18 अगस्त 20 अगस्त
Can
7 अगस्त
can somebody stopping? Can you
आ
please
रही है
stop? Please
ये देखिए
interrupting.
आप मुझे ऐसी की ऐसी कर दो मैं अपने आप है ना वो
ये आपकी बिल्कुल एज इट इज आप इसमें जो मर्जी देखते रहो 4 तारीख की मैंने आपको वो देखी
So I think, sir, there is no question from the participant end. Thank you for your very informative session on IoT, sir.
दो पेन ड्राइव
मेल नहीं करोगे
मेल कर देती है मीनू आ जाए इसमें मेल
कर दो मैं पे कर दूँ और कहते हैं बैंक की भी कर दो और एक मैं इसको ना 10 मिनट के निकाल दूँ
जो मुझे बोलो और ये पूरी टोटल आ रही है आपके पास जो पेमेंट रिसीव हुई हुई है वो सारी है इसमें आज तक की अगर कोई पेमेंट ऐसी रहती होगी जो अभी बैंक में क्लियर नहीं
Okay,
हुई
so the question by Ishant Munchal is that which hardware to use? The problem is, could you please
पेमेंट रिसीव वाली
moderate
कर रही
but
ये तो
disturbing?
पेमेंट रिसीव वाली है वो तो बैंक में अपडेट हो गई ना
Who is that who is talking? I don't understand.
रिसीव वाली तो दे रही हूँ
मैम पता है इससे क्या होता है जो उन्होंने हमें बताया था उन्होंने ये बताया था जैसे किसी स्टूडेंट ने पोर्टल पे पेमेंट कर दी आज कर दी
I don't
आज
understand.
इतनी
Who
जल्दी
is that?
नहीं आएगी
Any,
बैंक जरूरी रिफ्लेक्ट होगी नेक्स्ट आती है
so the question is, can we? What is the hardware to use? Please use something called depth cameras. So depth cameras are there, so that these depth cameras will help you to do a lot of things for automated. Search for depth cameras. No, the depth cameras has a lot of libraries and functionalities which you can program them. So that's good enough to use it. Though they are costly, so there people have built lot of stuff using them. So you search for depth cameras, you will get it. I think 29,000 or something is the cost, but they are good. You can think of using them. So any other questions? So best source of learning IoT. I I can't say it. So I will share my experience. So what you have to do is start working on microcontroller. So it has default examples. Then slowly start practicing. See what projects they announce in their page. So Arduino is a good page. Then slowly look at the magazines by Raspberry Pi. They keep publishing a lot of projects. They keep doing a lot of projects. That's where you start, and you should start practicing it. So more than learning, you should start practicing. Then obviously you will start, start doing more. So you can, if you want any more additional specific inputs or queries, you can. I have shared my email. You can send an email. So whatever I want, whatever I know, whatever we have explored, we will share it with you. Okay, thank you. Yeah.
Okay, thank you, sir. Thank you for joining us on this
Sure.
session. And sir, this is very practical and very informative lecture. And this will sure will open a new field for us in the field of IoT. Thank you for joining us, sir. With your kind permission, may I conclude the session, sir?
Thank you. Please thank once again to IMCA and others for giving a chance. Thank you.
Thank you. Thank you very much. Thank you, participants. We'll meet you tomorrow in the morning session. Thank you. Thank you all.